In this example, we are going to integrate or find the antiderivative of x squared divided by the square root of 121 minus x squared dx. And we're going to use trig substitution. I have our triangle already set up right here to get us started. And from the triangle, we can get a lot of information. We know that sine of theta is, oh, here's our theta. I forgot to write that in. Sine of theta is opposite over hypotenuse, so we would have x over 11. Solving for x, we would also have that x is equal to 11 sine theta. If I take the derivative, I get dx is equal to 11 cosine theta. And then at the end, we're going to have to back substitute to write everything back in terms of x. So we'll also need to know what theta is. So all we're going to do is take our formula right here. Nope, whoops, wrong one. Hold on. We're going to take this formula right here and use inverse sine. So if I take inverse sine of x over 11, that's going to give us theta. All right, so we have all the scratch work and the information that we're going to need over to the side. So to start off, I'm going to start substituting everywhere I see x. I'm going to write it as 11 sine theta. So this is going to give me x squared would be 11 sine theta squared. So that would be 121 sine squared. In the denominator, I'm going to have 121. And then when I substitute sine theta in for the x and square it, just like I did on the top, I'm going to get minus 121 sine squared theta. We still have this dx that we need to replace, and we found that down here. Dx is 11 cosine theta. So that's what I'm going to replace dx with. Oops, I forgot my d theta over here. Let me add that in. All right, now this is going to simplify quite a bit. I'm going to leave everything on the top the same for right now. Now, in the denominator, we have the square root of 121 minus 121 sine squared theta. 121 is in both of those terms under the square root. So I'm going to factor out a 121, and then I can pull out the 121 from under the square root as 11, because 11 squared is 121. So I'm going to have 11 here. When I do that, what's left under the square root would be 1 minus sine squared theta. And we know that 1 minus sine squared theta is equivalent to cosine squared theta. So now we would have cosine squared theta under that square root. And if I take the square root of cosine squared, then I would just be left with cosine theta. And now we have 11 cosine theta on the top and the bottom. So I can get rid of that. And we're left with 121 sine squared theta d theta. That's what we're going to have to integrate now. So it's simplified quite a bit. Now, using the tables, the integral tables from your OpenStax appendix, if you look at the integral table number 28, I believe, we're given that if I have sine to some power n theta d theta, that will simplify, or that will, when we find the antiderivative of that, we would get minus 1 over n sine to the power of n minus 1 times cosine of theta, and then plus a completely different integral, let's see, sine to the n minus 2 d theta. Now, when we apply this formula to what we have, we're going to have n is equal to 2. Whoops. And I also have to make sure that I carry down that 121 in front. So I'm going to have 121, and then inside we have our brackets. So now I'm going to apply this. Since n is 2, when I look at this here, I'm going to have negative 1/2 sine to the power of 1, because we have n minus 1 here, so 2 minus 1 would give me 1, times cosine theta, and then we have plus this integral of sine n minus 2, and since n is 2, we have 2 minus 2, and if we have some sign raised to the power of 0, that's just going to be 1. Okay, so let's carry this down and keep going. I'm going to copy all of this down. Now when I integrate 1 d theta, I'm going to get just theta, and then plus our constant. Now I need to distribute that 121. So I'm going to have minus 121 over 2 times sine theta, cosine theta, plus 121 theta, and plus our constant. Since our constant is just arbitrary, that 121 will just get absorbed into C. And so 121 times some random number would just be some other random number. So we'll just leave that as plus C. All right, now here comes the part where we need to back substitute. Our original question had everything in terms of x, so we want to go back and make sure that our answer is in terms of x. And this is where theta comes in handy. We need to change all of our thetas into sine, inverse sine x over 11, so we have everything in terms of x. So we have negative 121 over 2 sine, and then inside for the theta, I'm going to have inverse sine of, what was it, x over 11? Yeah, x over 11. And then times cosine of inverse sine of x over 11 plus 121 of, let's see, inverse sine of x over 11. Now let's simplify this. If I have the sine of inverse sine x over 11, that's just going to be x over 11. Now I'm going to have, I'm going to find cosine of inverse sine of x over 11. This, remember, is equivalent to theta. So if we go back up and look at our triangle, we'll be able to figure out what cosine theta is. Cosine is adjacent over hypotenuse. So cosine theta is going to be the square root of 121 minus x squared over 11. I think I messed that up. Hold on, let me double check. Yeah, this is just, sorry if I'm making you dizzy here. This is just x squared. I copied it wrong from the triangle. And then we have plus 121 sine inverse x over 11, and then plus our constant. Now this here, there's nothing we can really do to simplify this, but we can simplify this first expression. On the bottom, we have 11 times 11, which is 121. So that's going to cancel with this 121 on the top. And then we're left with negative x over 2 times the square root of 121 minus x squared. And then we still have plus 121 inverse sine of x over 11, and then plus our constant. So this is our final answer.